Okay, very well. Warm welcome to all of you uh, to this new session, new semester. I hope all of you are keeping well. So this is a new semester, and then we are having new classes and new syllabus, new course structure. Classes have already started. Are you attending other classes?
Yes, sir.
Okay, good. So, please speak when I ask you something, okay? Because I want this to be a sort of interactive session. And unless you speak, it is difficult for me to understand also. Because it is very different from the offline classroom environment. So, first of all, welcome to this open elective course, GIS and science. So, are you accustomed with GIS before? Little bit. Have you learned about GIS? What conception or what attracted you to the subject? Hello. Okay, GIS stands for Geographic Information System. Okay, and this course is going to be of 3 credit. This is an open elective course, and there is a syllabus which I am going to share with you. But before that, since this is the first class, let us talk about a little bit of background, and then we will progressively go into the subject. Okay. So let me share the okay, so can you see the screen? Can you see the screen?
Yes, sir.
Can you see the syllabus?
Yes, sir.
Yes? Please speak out loud, I cannot hear.
Yes,
Okay, good.
sir.
Yes. Someone was asking something? No? Okay, so hope everyone can see the detailed syllabus. The name of this course is Geographic Information Systems and Science. Okay, so Geographic Information System, the abbreviation is GIS, and then Science. The course code is, as you can see on the screen, OEEL 202. That is an open elective course. Total marks is 100. Out of that, you will have a 60 marks examination question paper, which will be evaluated on 60. And then you will be having your sessional examination or evaluation that will be of 40 marks. Then the total number of credits is 3. And in the syllabus, we have 5 modules. So this is the module number 1, which is the introduction. In introduction, I presume all of you are quite new to the subject. So we will start with the definition, then the history, then after that, what were the early developments in GIS and what GIS can do in terms of its capabilities. And one of the very important things, or most importantly, how the GIS is different from other IS. IS means information system. Okay. So this is going to be also a lot of practical self-doing, which will be involved in the course itself. So I hope for all of you, you have your laptops. Do you have your laptops back home? Someone doesn't have a laptop, please speak. Okay. Anyone doesn't have a laptop? You say, sir, I do not have a laptop. Who is there?
Yes, sir.
So, who is it? Please tell your name.
Sir, Bengi Eka, sir.
Eka. So, Eka, you do not have a laptop.
No, sir.
How will you manage it? Because in this course, you have to do it. Until and unless you self-do it, you will not be able to really learn the subject. So what I tell you, please get hold of a laptop as soon as possible. Okay? And then you install the software that I am going to teach you in between the course. Okay. So anyone else who doesn't have a laptop, please try to get a laptop, or try to get a laptop. Even if you cannot right now buy one, you can try to get hold of a laptop of some of your friends or your brothers or sisters, whoever is there with a laptop. Because GIS, everything is being done in a virtual environment, in a computer environment. Okay. So there will be theory part, but of course, until and unless you practice those theories and the things that you learn in a real GIS environment, you will not be really able to grasp the subject. Okay. So then what is the GIS? What the GIS can do? You will learn about the capabilities, what are the components of GIS, and why do you need a GIS? Because GIS has developed within a short period of time, since you will learn that for public use in general, it has taken speed since the late 1950s or in 1960s. So in that sense, it is quite a new subject. And then how it has revolutionized the whole concept of understanding spatial data. Spatial means S-P-A-T-I-A-L, that is related to space. Okay, the data that we see on top of the surface of the earth or in space, that is spatial, S-P-A-T-I-A-L, that is related to space. So you will learn how GIS has transformed the visualization of the spatial data. Then also there are some developments which have occurred over the time in terms of the current trends, and then in which direction actually we are heading with this new capability of GIS. Okay. Then also you will learn some of the concepts and components of this information system. And one of the very important thing is that you have to have a very clear idea about the coordinate systems. So I guess you have some idea about the coordinate systems that you have learned during your mathematical class or mathematics class. Basically, you need to have a set of reference, a frame of coordinate system, and then you will have a starting point, and from there on, you can locate a point on the space. So in GIS, we talk about latitude and longitudes and X and Y's. So these are the two basic coordinate systems that you will eventually learn. One is a three-dimensional coordinate system and another one is a projected coordinate system. So anything that is in terms of latitude and longitudes actually is a polar coordinate system. You will learn how we locate a point on the surface of the earth. It may be on the surface of the earth or above earth or somehow below the surface of the earth. Then together with the coordinate system, you will learn what is a datum and then how projections are handled in a geographical information system. So datum is a benchmark, okay? I remember when you were learning surveying, you must have heard about your datum. Okay, when you were doing leveling work or when you were using the theodolite, you need to have, or you were used to the concept of datum. Anyway, again, we will brush those things up here one more time. So that will be our first module. And as I said, I will go together with the theory as well as the practical classes. So in a week, maybe there will be a theory class, which will be followed by practical works together. And then I will teach you some of the fundamental works, how you should be using the GIS. And then we'll ask you to do the same thing. And then you will have to do it. And then you have to report me back. Okay? That will constitute your sessional marks. Okay, so from each module, we will be actually going together with the theory as well as with the lab classes, or lab means the hands-ons. Okay, then in module 2, there will be a little bit deep into the subject of data types and data models in GIS. So basically, when we are talking about data, there are different kinds of data that a GIS or an information system can handle. And then what is the spatial data and non-spatial data, you will also learn. Then how you input data into the system or the geographical information system. There are maybe various ways how you input data. One may be by scanning some of the images and then you take it to a software and then again digitize. Those are the techniques. Then what is the metadata? So metadata means data about data. So it necessarily constructs the quality of the data. That means if you have some items, for example, if you have some food in your house, or if you have some food in the fridge, how is the quality of the food? Okay. Similarly, in that terms, if you have some data in your hand, what is the quality of the data? What are the other attributes of the data? Is the data good enough for your research? Is this the correct data that you were looking for the particular research? So anything that describes the data that you are holding or the data that you are going to capture or the data that you are going to receive, that is known as metadata. Okay, so metadata is basically the data about data. So what is metadata? How metadata files are handled? How metadata should be read? What inferences can you draw after reading a metadata in the standard format? What are the standard formats of metadata? All these things we will learn in the module 2. Okay, then it will be a conversion of existing data. For example, as I said, there are different data types or data that the GIS can handle. How you can convert this data from one format to another. For example, if you have a photograph or if you have a scanned image of a certain area, from that image, how you are going to extract the roads or how you are going to extract the boundary of some of the houses. So that means from the image you are drawing, and in the drawing board, when you draw that, the outline or the line or the point or the area is being converted into a different type of data. Okay, so that means from one format to another, how will you convert? And from that format to the previous format again, how can you go back? Okay, there may be different types of data, how you go for conversion of these data or data. So that is a part of this module 2. And even if you do not want to convert, in that case, how you will be creating new data. That is the creation of new data. In GIS itself, you can create data. Then data models are there, okay? Then vector data model is there. So within the vector data model, we have different kinds of data types or data models. Then we have raster data models. I think someone, if you are from computer science or engineering, they may be a little bit familiar with the subject. Is there anyone who is from computer science here in the class today? Can you please tell your name? Anybody from computer science? No? Can you hear me?
Yes, sir.
So are there students from computer science here?
Yes, sir.
Okay, can you tell me your name? Speak up. I cannot hear. Hello. Do not feel afraid to speak. What's the name of the student from computer science? What kind of a student are you? Okay. So those students who are from computer science, they may have some rudimentary idea about various data types or data models. But for other students who are from non-computer science background, you do not have to be really afraid, even if you do not know about these things before, because we will be learning these things all over again. And then this is within the course or in the syllabus of the subject that we will be learning these things. Okay. So data types and then data models basically are two types. One is a vector data model, another one is a raster data model. And then we are going into integration and comparison of vector and raster data models. So between these two data models, there are some of the advantages and disadvantages. And in certain cases, these models, one is more favorable to the other. So we learn how these two data models are handled in a GIS system. Then the ultimate goal of this whole course is that you do by yourself some of the small things so that you will be able to extract information out of an image, or you are able to go on with some of the very rudimentary type of small project work involving GIS. So for that, you need to understand a little bit of image processing. So image processing means if I give you an image, it may be any sort of an image, how you are going to increase the brightness, how you are going to increase the contrast, how you are going to enhance the edges of the image, or how you are going to blur the image. So these all things you are doing in so many softwares nowadays available, but what actually is being done when you really want to enhance these images in terms of digital numbers of those images, okay? So those things you will learn. Suppose you want to increase the brightness of the image, suppose you want to increase the contrast of the image, what actually is happening in the image itself. So those are the things that you will learn. And then I would preferably asking you to install one GIS system that is known as a QGIS. So there may be other GIS, preferably whatever GIS system you will be comfortable with. It's upon your choice, but some of them are not really open source. So QGIS is an open source GIS system, or GIS, sorry, and then you don't have to really pay for it. You can directly go to internet, Google it, and then install it. There are other GIS packages. One of the very famous one is known as ArcGIS. So if you can get a copy of the ArcGIS, maybe you can install it in your machine and it will work as well. I think some cases both are comparable. Some cases QGIS is better. In some cases ArcGIS is a better or preferred one. Okay. So until the end of module 2, you should be able to install GIS, and then you would be able to play with the system. Then in module 3, you should be starting to analyze data. What kind of data? These are spatial data, SPATIAL. That is the whole purpose of the work. So first one, we will start with digitizing. You will know what is digitizing. Then there are types of digitizing errors. You will also learn about the errors, how the errors are calculated, how the errors can be minimized, what are the possible sources of error. So we will learn about those things. Then you will also learn about topology. What is a topology? Okay, or how you can edit the topology of these type of data. Then one of the very important things of GIS is also to query or to question your data. That means with every GIS there is data. So this data is related to one table or form that you will come to learn. So if you are dealing with some sort of spatial data, each data is associated with a table. So what is the purpose of this table? So that you can query or you can question the system to get an answer. Okay, for example, before we start, let me give you an example. Suppose you all are situated in different places now because we are not in the classroom. Some of you are in Arunachal Pradesh, some of you are in Meghalaya, maybe some of you are in Mizoram or maybe in Nagaland. So if I plot your locations into a GIS right now, and then I want to question the system, give me the name of the student who is right now residing at the farthest distance from the university. Okay, so the system will question or query the table associated with all the data and then give me one result. So out of suppose maybe 90 students, I will come to know that there is one student who is right now situated at the farthest point from downtown university. Or again, I can question, suppose, give me the name of the student who is residing at the highest elevation. That means in terms of the height from the sea level, all the datum you will come to know, the GIS will calculate the height at which all of you are now sitting. That means the height of your house. You may be sitting or you may be residing in hills. Okay, so who is actually at the highest point? So in that sense, I can quickly get an answer. So this type of things, when you ask the system, it is known as a query or questioning. And then immediately the system is able to deliver me the result. Okay, so some of these are queries which are non-spatial. That means that there is nothing to do with space. Some of it has to do with the space. So there are special queries, and then there are some other kinds of operations which you will eventually come to learn. And then depending on the data type, it may be a vector-based analysis or it may be a raster-based analysis. So one of the very important things in module 3, you will learn about digital terrain analysis and modeling from the point of view of civil engineering. Digital terrain refers to the undulations or the unevenness of the surface of the earth. Okay, so as I said, some of you may be sitting, or some of your houses are located in top of the hills. Some of you are located at the plains. Some of you are actually located at a depression. Maybe it is from the mean sea level if we calculate. So digital terrain actually refers to these undulations. So if we take a satellite image, or if we get an information about the heights and the depressions of an area of interest, this itself is known as the digital terrain. Okay, so that will be the work of our module 3. Let me see. So far, can you hear me clear and loud? Can you please say?
Yes, sir.
Yes, sir.
Okay, good, good, good. Okay, then going to our module 4, as you see it on the screen, GIS actually is not a very stand-alone product. So it has to work together with some other devices or other systems. So that makes it complete in a sense. So from that angle, GIS has to work with different types of data, and then these various types of data are gathered into the platform of GIS through various devices or various other ways. So one of such ways is known as remote sensing. I don't know if I have told you enough in the surveying class about remote sensing, but again, we will brush up the things there. Remote sensing is all about collection of data remaining at a distance without being directly in the contact of the object of interest. So there in the module 4, you will learn about the basics of remote sensing, then how you interpret the data gathered by the techniques in remote sensing, Basically, these are all images which are digital images. That means we talk in terms of 0 and 1. Okay. And again, data acquisition techniques, how different satellites are engaged in the collection of various kinds of data, especially for remote sensing. There are different satellites. Some satellites are involved in the collection of these undulations that I just mentioned. Some satellites are involved in the collection of temperature. Some satellites are involved in the collection of data related to the vegetation. That means if you have a plot of land, you have a piece of land and you are growing crops there. So from the satellite image itself, I can tell how good the growth of the crop is. Or if you are having a plot of land where you are, suppose you have a fishery, growing in that fishery, you will be able to tell from remote sensing image or remote sensing data. So there are various different satellites which are engaged for different purposes. Not all satellites can be used for all kinds of work. Depending on the type of work, we will be using different types, so our selection of the satellite data will be different. So that you will learn in this module 4. Then how these satellite images are actually searched over the internet, because all these satellite images are not free. Some satellite images are very costly, but some satellite images are actually free. So if you really want to know about your place, suppose how in some area in Nagaland looked like in 1972. So in that case, you'll have to go and then search in internet a particular area of your interest, and then how this area looked like in 1972. If you have the right kind of image, you can download it and then you will be able to extract information. For example, you wanted to know what was the forest cover of Arunachal Pradesh in 1972, and then how progressively this forest cover, if you think, is deteriorating, you can quantify it simply by downloading images and then analyzing how much of a land is being cleared in successive years in 1980, 1985, 1990, 1995, 2000, so on and so forth. So that's a very powerful tool from that point of view. So the remote sensing image will give you the satellite images, and then the GIS will be allowing you to analyze these images in that particular environment, particular information system. Okay. And then together with remote sensing, GPS is also one of the important instruments or one of the important techniques with which we want to create data. So GPS is, you all have been using it right now, even in your Google map, or if you are driving. This is geographical position systems, okay? So how these things work, how many satellites are there, which are the organizations which are providing these services to the whole public of the world, and then ultimately how you are going to using all this information coming from different sources, you are going to create a map. That means your ultimate data has to be produced for someone so that it can deliver some meaningful information. So that meaningful information will be in terms of maps that you are going to create. So ultimately in GIS, you will have to create a map, and then in the process of creation, you need to learn the techniques. So in module 4, you will learn those techniques. Then the last module is related to geostatistical analysis. So from the point of view of doing research, you have to quantify things, okay? It means that you have to talk in terms of numbers. So numbers are meaningless until and unless you have some tools of analysis. So these tools are basically the tools of mathematics and statistics. So if I have a class, within the class, there are 59 students. So for example, right now in the class, if I look at the participants, the number is 59, including myself. So I can assume that there are 59 people who are actually engaged in this particular classroom. So if I want to extract some sort of information relating to the internet availability or the bandwidth of all the 59 students here, there will be various different numbers that I will be ultimately getting from all these devices that which are logged into this particular session in an online mode of communication. So everyone out of all the 59 students, you will be availing different bandwidths, some of which are good, some of which may be poor, or some of which may be very worse. You are logging out, logging in most of the times. So ultimately these bandwidth numbers may be in megabytes or something, whatever unit, I'll get sometimes some numbers. So statistics, by using tools of statistics, I can get some information about the quality of interactions that is happening here. For example, if I want to see the average or mean bandwidth, all the students, or 59 students, I will get one number, right? All these bandwidths, you add it up and divided it by the total number of devices. So that will give you the mean number, the maximum, okay? Then the minimum, that will also be possible to get. Then the range, then I can get the skewed information. What is the skewness? Or I can get the kurtosis, how peak, okay, how flat, those kind of information. And then going a further step further, one or two steps further, I can also try to get information related to the standard deviation. How many students are within one standard deviation range of this bandwidth? Okay, this sort of information. All these things are known as statistical analysis. But what we will learn here in Module 5 is those statistical tools when you are going to analyze in data which is related to space or geography, which is known as geostatistical analysis tool techniques. So since our whole purpose of GIS is something to deal with spatial data, then we will be using these tools of geostatistical analysis or different techniques of geostatistical analysis. For example, one of them may be some of the regression models. So if I want to tell you about, suppose, the level of concentration and then the marks achieved in the final examination, there may be a linear relationship. So some student who is paying more attention to the class, he has a better chance of scoring. Okay, so there is a linear relationship. If one increases, another also increase. So ultimately with these two values, you try to find out a relationship which is known as a model, and in this case it is known as a regression model. Okay, so that is, we have to formulate these models in terms of our data that we will get. Then we'll also deal with the Thiessen polygons. Furthermore, you will be learning these things. Then what is IDW interpolation? So what is an interpolation? First of all, you will have to learn. Then what is in different kinds of interpolation, which involves IDW. Then also you have to Kriging, that is a probabilistic interpolation. Then how GIS is used for decision support systems. So ultimately, as I said, GIS is, the whole purpose is to take efficient decisions. You are not going to create maps for no purpose. Your whole purpose is to take some decision, and then those decisions, so that you take efficient and good decisions, there need a system, and then GIS actually is the system. It provides you with helping in the decisions. GIS is the system, that system helps you in your decisions. So how GIS helps in those decisions, okay? Then you will also learn about AHP, that is known as analytical hierarchical process. What are the basic principles of AHP? Some of these things means from people's perceptions, how you are going to convert their opinions and perceptions into something which is quantifiable. You will be learning through AHP. And then ultimately, you need not be working in your desktop or laptop all the time. Ultimately, nowadays, it is the days of online. So GIS has also become online. So it is all about web GIS nowadays. This is quite interactive. You can dynamically see the changes, and then whatever data or report that you have found, you can produce it over the internet through the help of web GIS. Okay, so this is basically the 5 modules that contains within this class. And then, as I said, I will be very happy to make this class interactive. That means I will ask 2 questions, and I want you to be actively engaged in these question and answer sessions. You need not be fearful of a wrong answer, okay? But the most important thing is that you take part and then you speak. That is, I say all the time, you have to speak. Okay, so I think we will be closing this first session today, and then maybe after 10 or 15 minutes, I will give you another link, and then we will come online for the second class, okay? Because we have 2 classes right now, back to back, is it? Yes or no? Huh?
Yes, sir.
Don't we have 2 classes today?
Yes, sir. We have 2 classes.
Okay. So let us go for some break, and then I'll give you another link to come online. Okay.